In this video, I'll explain how to do integration by parts. We use integration by parts if we have, or if we're integrating a product of two functions. Like in our case, we have x squared multiplying cos x. So these are two functions. X squared is a separate function and cos x is a different function. We want to integrate this. If we look at our integral, we don't have any other choice but to use integration by parts. So we use integration parts by parts when we encounter a situation like what we have now. So I'm going to explain how you do it. This is the formula. It may be given in different ways. Some textbooks or some syllabus, they use U and V. It is presented in different ways, but this is also a very easy way to present this formula. So one of the functions, we're going to choose one of the functions to be f of x and the other function to be g prime of x. All of these terms that we see in our formula, we have to find them and then we substitute. That's our task. Now, the challenge is on choosing, the first challenge is on choosing f of x and g prime of x. With experience, you do it easily, but there are some rules of thumbs that you can use. Like in our case, we have x squared and cos x. The function that we're going to choose as f of x should be a function that we can differentiate. Why? Because to the right hand side, we have f prime of x, which means we should be able to differentiate whatever we choose as our f of x. Then we have g prime of x to the left, and to the right we have g of x here. It means this function that we're going to choose as our g prime of x, we should be able to integrate it. That's it. But in our case, if you look at what we have, we can integrate and differentiate both of them. X squared can be integrated. X squared can also be differentiated easily. Cos x can be integrated, and cos x can also be differentiated easily without any challenge. Now, the next thing that we look at is which of the two functions disappear or dissipates into a constant over successive differentiation. If we look here, if we differentiate cos x, it does not dissipate. It becomes sine x, comes back to be cos x, goes back to be sine x, and it does not dissipate. But if you look at x squared, if we differentiate x squared first time, we get 2x. If we differentiate the 2x, we get a 2. This function becomes our best choice for f of x. The function that on successive differentiation, it dissipates into a constant. And that's what you choose as your f of x. Sometimes if you have two functions involving something like ln x, almost always when there's ln x in another function, that function of ln x is the one that you're going to choose as your f of x, because you can easily differentiate. In fact, you don't have much choice there. You have to choose it as your f of x. But as I said, with practice, you end up being aware of which one do you choose as f of x, which one do you choose as g prime of x. It goes with practice. There's a simple rules that you need to use to make that choice. So let me show you how we do this. Now we're choosing our f of x as x squared. I have explained why we're choosing f of x as x squared. So f of x is x squared. This means our f prime of x is 2x. We are choosing our g prime of x as cos x. So g prime of x is equals to cos x. This means g of x is the integral. We integrate to get g of x. We integrate g prime of x to get g of x. So the integral of cos x dx. If we integrate cos x, we get sine x. So our g of x is sine x. That's it. So now we have all the elements in our formula. We have f of x, we have g of x, we have f prime of x, we have g of x. The next step is simply to substitute all these into our formula. That's our next step. So let's go to the next step. I'm just going to write what we're going to have. So it's integration of x squared cos x dx. This is now equals to f of x times g of x. That's x squared times sine x minus the integration of f prime of x, which is 2x, times g of x, which is sine x dx. This is our equation. However, if we look at this equation, we still have a problem here. The problem is that 2x and sine x cannot be integrated unless we use integration by parts again. So this means we have to apply integration by parts again. So let's do it. Now let's have our f of x. Again, I'm going to use a different pen. Now our f of x this time is 2x. From here we can find f prime of x, obviously, is 2. Our g prime of x is sine x. This means our g of x, which is the integral of sine x. If we integrate sine x, we get minus cos x. We now have to substitute back into our formula again. Don't forget what we have. So we're just continuing. I'm going to rewrite this as integration of x squared cos x dx equals to x squared sine x minus, I'm going to put a bracket here. Now I repeat the same formula for integration by parts. F of x, g of x. So our f of x now is 2x. Our g of x is minus cos x minus integration of 2, which is our f prime of x, times g of x, which is minus cos x dx, okay, times minus cos x dx. All I'm doing here is simply substituting into my formula. So I close this bracket here. I simply substituted again into the formula for integration by parts. Let me simplify this, which means just removing the brackets here. This now is x squared sine x. There is a minus here and a minus outside, so it's going to be plus 2x cos x. There is a minus here and a minus there, and we're multiplying this by minus. So in the end, in the end it's going to be just a minus and integration of 2 cos x. We can put the 2 outside here and put cos x inside dx. Now, what we have here under the in the integral side, this integration here, is straightforward. We can integrate cos x, so we no longer have any problem. We can finish our answer is x squared sine x plus 2x cos x. If we integrate cos x, our answer is sine x. So this becomes minus 2 sine x plus a c. This is our final answer. So in this question, we applied integration by parts 2 times. We can also apply it 3 times depending on the question that we're given. But it means you can apply integration by parts until you no longer have to apply integration by parts. This is one situation. We have a different or another situation where if we keep doing integration by parts successively, it does not end, it does not stop. There is a different way of approaching that question. I'm going to do another video where I explain how to do integration by parts in a situation where successive application of integration by parts does lead to sort of like a recurring integral that you cannot get rid of. That's another situation. I'm going to explain it another day. But in this case, we have applied integration by parts 2 times and we managed to evaluate our integral.